Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, An Academy. An Academy is the India's largest online learning platform. Now, we are happy to announce that An Academy is going to providing online training for GATE and engineering service exams. About myself, I G Venkatrao. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am doing PhD from JNTU Kakinada and my specialization is VLSI domain. Now, first we check how to get an Academy Learning app into your device. Just go to Play Store, type An Academy and it will show the An Academy Learning app like this. By clicking on this install button, it will install the An Academy Learning app into your device. Now, this is very important thing. First, you should know why should I join in an academy. By joining an academy, what I get. First, we check that what you will get. Every day you have a live class. Your course is well structured with your exam syllabus. And regularly you have live tests as well as quizzes and unlimited access you get. Now, what it means? Daily live class. Every day you have a live class. The intention behind to conduct live class on every day is always to keep the student in touch with the subject. With that intention, we are conducting online class every day. In that live class, you can chat with your educator, means faculty, engage in discussions. You can discuss with him, the faculty, and you can ask your doubts and you can answer the polls. You can do all these things while class is going on. After that, structured courses. See, all our courses are structured in line with your exam syllabus. In line with your exam syllabus to help you best to prepare for it. To help you best to prepare for it. And see, whatever the exam syllabus we have, it is for every course, it is structured well with your exam syllabus. Next, live tests and quizzes. See, to evaluate your preparation, with our regular mock tests and quizzes. So you can evaluate your preparation. After completion of your preparation, you can evaluate it with regular mock tests and quizzes and get the detailed analysis on your performance. After that, from the analysis of detailed analysis, you can identify the gaps in your preparation and try to fulfill those gaps in your preparation. Unlimited access. Unlimited access. What it is? Once you are taking a one subscription, now you can get access to all our live and recorded courses. You can take the live and recorded courses. You can access. And you can watch from the comfort of any of your devices. You can watch it from the comfort of any of your devices. These are the benefits you get by taking an academy subscription. Now, there are two subscriptions. Iconic subscription. Iconic subscription. Next, plus subscription. Plus subscription. In plus subscription, just before, what are the things we discussed? Daily live classes, structured courses, live tests and quizzes, and unlimited access. You get all these things by taking plus subscription. By taking plus subscription, you get all these things. Okay. Now, iconic subscription. In iconic subscription, you will take your preparation to next level with your personal coach. Here we are providing a personal coach to each and every individual student who take an iconic subscription. And first of all, what are the benefits got by the plus subscriber? you get all these benefits. What are the benefits got by the Plus subscriber? You get all these benefits. In addition to these benefits, you get a personal coach. Next, study tracker, mains question and answer practice. Now, what is personal coach? What is the meaning of personal coach? See here, you get one-on-one guidance from top exam experts as your personal coach. One-on-one guidance from top exam expert. The top exam expert who you are taking, who you are allotting to you, he is your personal coach. Now, his function is, once you've written some exam or you attempted some quiz, based on your performance in that, they will prepare proper study plan and respective study material to you. Okay, they will provide those two to you. By following those two effectively, every student can get success in their examinations. And at the same time, in study tracker, you can evaluate your progress. Study progress in weekly reviews with your personal coach. How much preparation is completed you can evaluate it by weekly reviews with your personal coach. Now for that, you need to participate in study tracker plan and study booster workshops. For that, you need to participate in study booster plan and study tracker plan and study booster workshops. After that, the most important thing is mains question and answer practice. See, in engineering service, you are going to attempting mains paper. You are going to attempting one mains paper you are going to be writing. In that mains paper, you need to write the answer for each and every question. It is not like a objective in GATE exam. It is a descriptive. You need to write the answer to your question like your semester exams. Okay, now you need more practice for answering those questions to strengthen your capability, to strengthen your capacity of writing the mains questions. Because in that, you need to know where you need to stress, where you need to compromise, which topic has to be highlighted, which derivation has to be done, which formula has to be prepared. Okay, everything you should know. For that, you need a regular preparation, regular practice. So you can strengthen your mains answer writing through regular practice, and you can strengthen that with evaluation and personalized feedback provided by us. We provide a personalized feedback to you by evaluating your questions what you've written. Okay, these are the additional things you get by taking Iconic subscription compared to Plus subscription. So in Plus subscription, what are the benefits got by the Plus subscriber? You get all this. In addition to that, you are getting this personal coach, study tracker, mains question and answer practice. Okay, next one. Yeah, now Unacademy Combat is going on. It is India's largest online scholarship test. In this, if you get the rank 1, 2, 3, top 3 ranks, you are in top 3, you get the complimentary Unacademy Plus subscription for 1 year. And if your rank is between 4 to 10, you get 75% off on Unacademy Plus subscription for a tenure of your choice. Either you go for 6 months, 12 months, 18 months or 24 months, whatever it is. After that, if your rank is 11 to 50, you get 50% off on Unacademy Plus subscription. See here also tenure of your choice. And if your rank is 51 to 100, now you get 25% off. 25% off an Unacademy Plus subscription. Here also tenure of your choice. Okay. Now, what is this scholarship test actually? What we get during scholarship test, what we get, and what are the benefits I got from this scholarship test? See, first of all, you are going to writing India's largest weekly competition for GATE. India's largest weekly competition for GATE. And you can assess your GATE preparation in 60 minutes. Within one hour, you can assess your preparation. And we are challenging that original GATE questions you get in that exam, and which was curated by our best educators. And you can take it live to compete with the best. That means we are providing a live ranking, all India live ranking. Okay, compared to the topper, compared to the best where you are, because all India live ranking they are providing. Even though you are getting 90 percentile, 95 percentile in GATE exam, okay, but the important thing here is what is the GATE rank? Okay, that is the important thing. So compared to the topper where you are, so to get that, you need to write, take a test test it live. After that, super fast and fun with all India live leaderboard. Here it means compared to now, based on your fast and accuracy of answering a question, your rank is going to be changing for every combat. That means for every answering of every question, your ranking is changing. And after that, completion of all things, we are providing a detailed video solutions to you. From this detailed video solutions, we are going to identify and improve your weak areas. After writing the exam, you are unable to answer few questions. That means you are weak in that area. Now you can improve your weak area by detailed video solutions which was provided by our side. Now next combat is on 9th March. 2nd March is our 9th May. 2nd May is completed. Next combat is on 9th May. Will start at 11 AM. Don't forget that. And these are the different departments: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. These are the eligible branches. Okay, and to unlock, use my code VROUT10. Now, see, this is the enrollment guide for this scholarship test. First, you can enroll for free from your Android. From your Android mobile, you can enroll it for free. After that, you can appear live for the test. Appear live for the test. So you can write the exam, and after that you get the detailed video solutions. By view that video, detailed video solutions, you can increase your knowledge, enhance your knowledge, and daily, weekly practice these things. Weekly practice these things, and finally you win the scholarships. Okay, so by following this procedure, definitely you get the scholarship. Next, we are going to transistor at high frequencies. Now we are going to analyzing our transistor at high frequencies. Okay, now how to analyze that? Now it is a high frequency analysis. High frequency analysis. See here, in high frequency analysis, so your amplifiers are analyzed at high frequencies by considering the effect of small frequencies, sorry, small capacitors, okay, and large capacitors are short circuit at high frequencies. Okay, now first I am writing that amplifiers are analyzed at high frequencies high frequencies by considering the effect of small capacitances whereas large capacitances are considered as a short circuit. Short circuit. Okay, large capacitances are short circuit. Now, small capacitances, you are saying small capacitances means of the order of picofarads. Small capacitances are of the order of picofarads. Now, I am going to taking, there are two types of small capacitances. There are two types of small capacitances. External capacitor as well as internal capacitance. Small capacitances are going to decide the high frequency analysis. Small capacitances of the order of picofarads. Now, here there are two types of small capacitances. One is external capacitor, other one is internal capacitor. First one is a external small capacitor. Second one is internal capacitor. Internal capacitor. External capacitors are your shunt capacitor or connecting a shunt capacitor or load capacitor. Connecting a shunt capacitor or load capacitor. And here internal capacitors are junction capacitances. Junction capacitances. Of BJT. Junction capacitances of BJT. Okay, now in this external capacitors, they are connected to, they are using, most of the cases they are using to get the desired bandwidth. Okay, connected to obtain desired bandwidth. To obtain desired bandwidth, we are connecting these external capacitors to that. And in junction capacitance, we have two junctions in transistor: base emitter junction and collector base junction. One junction, once we are using your transistor as an amplifier, it should be operate in active region, and in active region, emitter junction, that means base emitter junction is in forward bias and base collector junction is in reverse bias. Okay, now I am going to representing that. So once junction is forward bias, there is a diffusion capacitance takes place. Now I am writing that diffusion capacitance of emitter junction of emitter junction JE, because your emitter junction is in forward bias, and after that we have a transition capacitance at collector junction. Next, transition capacitance of collector junction. JC. Now this collector junction is in reverse bias. Collector junction is in reverse bias. Okay. These are the small capacitances. So small capacitances are responsible for high frequency response of your amplifier. Now your higher cutoff frequency is measured from this. Okay. Now in the bandwidth calculation, higher cutoff frequency plays an important role, because in general lower cutoff frequency of the order of ohms or kilo ohms, but higher cutoff frequency is 1,000 times more of the order of kilo ohms or mega ohm, sorry, kilo hertz or mega hertz. I'm sorry. Okay, so it is very large. So higher cutoff frequency plays an important role in the measurement of bandwidth. So for that, these values are depends on the small capacitances which are present in your circuit and in your device. In your circuit means they are external capacitors. There is a shunt capacitor or load capacitance, okay, which is connected to obtain the desired bandwidth. And in internal case, we have junction capacitance of your BJT, that is a diffusion capacitance, diffusion capacitance of emitter junction, and transition capacitance of collector junction, because your collector junction is in reverse bias. Okay, these are the different small capacitances we have in an amplifier circuit. Okay, now next, see what are these small capacitances. We are not using these small capacitances in H parameter model. Okay, and we are using these things only at high frequency analysis. Okay, now this high frequency analysis is performed by using two ways. High frequency analysis is performed by using first one, high frequency pi model. High frequency pi model. Second one, high frequency T model. T model. Okay, so this is the famous one. Now we are going to work out on this. Okay, before going to that, I am going to getting now high frequency equivalent of transistor. That means high frequency pi model is also called as hybrid pi model. Hybrid pi model. Okay, now I am going to that hybrid pi model. Hybrid pi model representation. So here I am taking the hybrid pi model representation of transistor BJT. So for better understanding, first I am going to drawing the transistor. So it is collector, base, emitter. This is emitter and it is the base. it is the base emitter, it is emitter, sorry, it is collector. Now let us take a NPN transistor or PNP transistor, whatever it is, choice is yours. Now my intention is to get the hybrid pi model. That means at high frequencies how it is. Just before you mention, in high frequencies internal capacitors are there. That internal capacitors are playing an important role. So emitter junction capacitance and collector junction capacitance. Now I am going to placing two capacitances here. Two capacitances here. After that, and this is the base emitter junction capacitance, this is a base collector junction capacitance. After that, now we are doing high frequency analysis. At low frequency, what happens is, once your input signal reaching this point, your transistor action starts on this signal from this point, at this point, because at this point it is entering into the base. Now that means your signal feeling that I am entering into the base terminal of the transistor, base region of the transistor. This is base terminal, this is the base region. Once it entered into base region, it obey the rules and regulations of the base. Okay, that is a regular signaling we are expecting in regular signal. Now here we are applying high frequency, don't forget that. Now you may ask one thing, sir, if it is high frequency, what is the difference? Then what happens? See, now I am comparing the low frequency and high frequency with an example. Low frequency I am comparing with a person coming on a bicycle, and high frequency comparing with a person coming on vehicle, two-wheeler, bicycle. That means a bike and a person coming on bicycle. Now once he reached this point, I am saying stop there. Now immediately person is stopping there itself. But in case of bike, once a person is coming on a bike, once reaching this point, I am saying stop there. Then immediately what happens? While traveling some distance, he comes to rest. That means your signal is traveling. Now your signal is low frequency signal. Once reach this point, it feels that I am entering into the base region. But in case of high frequency signal, by traveling some distance into the base, it feels that I am entering into the base. From this point onwards, it feels that I am entering into the base. I am in the base region. At this point, it feels that. Now on this signal, from this point onwards, base action starts on this signal. Now this is a p-type semiconductor, additional p-type semiconductor, and the amount of resistance offered by that one I am representing like this. This is your base. Now let us take it as B dash. Okay, and at output side, transistor is a basically current device. Now I am representing that current device. This is the current. Instead of taking that current, now I am representing that current in terms of transconductance, GM into VBE, input voltage. But instead of VBE I am taking here, this is input voltage, and this is your input voltage. VB dash E. Because your signal by reaching this point, it feels that entering into transistor. So GM into VB dash E. At the same time, there is a resistance. We have a property in transistor, that is base width modulation. To represent that base width modulation, here at output I am going to placing a resistor RCA. At the same time, once at this junction, not only this junction capacitance, some dynamic resistance also takes place at the junction. In forward bias, forward dynamic resistance; in reverse bias, reverse dynamic resistance. Now I am going to placing that resistance also here. This is the hybrid pi equivalent of the transistor. Okay, now I am going to giving names to this. This is a C. It is a C B dash C, R B dash C, R B dash E, C B dash E, and it is RC between collector to emitter. Okay, now whatever the structure I mentioned here, that is the hybrid pi model representation of the transistor. Now I am going to place representing this one in a proper order. First of all, we are going to common emitter configuration. That's why it is a common emitter. So it is common emitter. At input side, we have circuit like this. Now this is emitter. It is collector. It is base. Okay. Now, if you observe this, from base to we start our journey from base. Now base to B dash, I want to travel first. Now B to B dash, there is a resistor. I am calling it as RB dash. From B to B dash, there is a resistor. So there is a resistor from B to B dash. So now this is B dash. So RB B dash, RB B dash. Okay. Now we are at B dash. In B dash, from B dash, I am going towards emitter side. Towards emitter side. So there is a capacitor parallel with a resistor. So there is a capacitor parallel with resistor. So there is a capacitor parallel with resistor. And the values are RB dash E, CB dash E. And from B dash to collector, B dash to collector, same CB dash C, RB dash E. Resistor parallel with capacitor. Resistor parallel with the capacitor. So it is CB dash C, RB dash C. Now, from collector to emitter, GMVB dash E and RCE. There is a current source. And a resistor RC. Gm into VB dash E. So this is the VB dash E. That is VB dash E. So here we have a VCE. Now here we have VB. This is IC. This is IB. This is the hybrid pi model representation of transistor. Okay, now in general, CB dash E is represented by C pi and RB dash E represented by R pi, or sometimes its conductance. At the same time, CB dash C represented by C mu, as well as RB dash C represented by R mu. Okay. Now, this is called RBB dash is a base spreading resistance disturbance. Now, so here RBB dash is called base spreading resistance. Of the order of 100 ohms it is. In general it is of the order of 100 ohms. Okay. So next one is RB dash E. Okay. See, you get this by, this is the forward resistance of forward biased PN junction diode resistance, or dynamic resistance of forward biased PN junction diode. Okay, dynamic resistance of, or forward dynamic resistance, simply forward dynamic resistance. Dynamic resistance. So it is approximately 1 kilo ohm, and you can get that by taking the reciprocal of the input characteristics of transistor in CE configuration. By that also you can get that. Okay, and already we mentioned C pi and C mu. CB dash E is nothing but a C pi. Its value is approximately 100 picofarads, and CB dash C is C mu, we called it. Its value is approximately 3 picofarads. 3 picofarads. Okay, these are the values. And one more, we have RB dash C. It is the forward dynamic resistance is RB dash E. Now RB dash C is the reverse dynamic resistance. RB dash C is the reverse dynamic resistance. Reverse dynamic resistance. It is of the order of 4 mega ohms in general. So RB dash C is much greater than RB dash E. In future we are going to using that one. We need to relate combine this RB dash C and RB dash E. At that time, you can take RB dash E plus RB dash C is approximately RB dash C. That's enough. Okay. And GM is the trans conductance, which is mod IC by VT, volt equivalent of temperature. And RC is the output resistance, or it is the reciprocal of the slope of the reciprocal of the output characteristics of transistor in CA. Okay. Now it is going to model your early effect. Whatever the early effect we have in our transistor, it is modeled by this RCA. Okay. It models the early effect. Early effect. Okay. In general, it is high value. These are the values of this, meaning of this. But in general, these except this one and this one are represented by conductances. Represented by conductances. Now it means GB dash E is 1 by RB dash E, which is input conductance. Input conductance. After that, GB dash C, which is 1 by RB dash C, which is a feedback conductance. Feedback conductance. After that, GCE, which is 1 by RCE, output conductance. Output conductance. Okay. Now in terms of these conductances, I am going to redrawing this. So it is RB dash GB dash E C pi C mu GB dash C GM into VB dash E GCE. This is output voltage VCE. Here is the voltage VBE. And this is VB dash E. And the current is IB. This is IC. Okay, this is the hybrid pi model representation of your transistor by considering, in terms of conductances. Okay, now I want the equations for this RBB dash, GB dash E, GB dash C, okay, and GB GCE as well as capacitors. First we calculate the values of resistors and conductances in that. After that we calculate the capacitance values. Okay. Now first I am going to calculating that. For that process, in that process, what we have to do is we are going to calculating these values by in terms of known common emitter H parameters. Now this hybrid pi parameter values are calculating in terms of known common emitter H parameter values. Okay. But common emitter H parameter is applicable at low frequencies, but it is applicable at high frequencies. Okay, so to equate both, you need to convert this one into a low frequency, or you need to convert H parameter into high frequency. Okay, instead of going to converting that, what I am doing is I am going to converting this one into its equivalent low frequency. Okay, now first I am going to writing that. Now first I am writing the small signal equivalent of low frequency equivalent of hybrid pi model. I want that after that to calculate those parameters in terms of H parameters. So low frequency equivalent of one thing. Next slide I will write that. See, at low frequencies what happens? Whatever the capacitors C pi and C mu we have, they are open circuited. That's it, not more than. Now we need to calculate. So you can expect the calculation of these parameters in IE engineering service. We need to calculate hybrid pi parameters. Hybrid pi parameters. Now they are calculating in terms of known H parameters. They are calculating in terms of known H parameters. Okay, but H parameter is applicable at low frequencies. H parameter representation is the low frequency representation, but H parameter is the low frequency representation. Low frequency representation of transistor. Of transistor. Okay, low frequency representation of transistor. So to calculate that, first we need low frequency representation of hybrid pi model. So therefore we need low frequency equivalent of low frequency equivalent of hybrid pi model. low frequency equivalent of hybrid pi model. So therefore at low frequency, simple, at low frequency, what are the capacitors we have? C pi and C mu are open circuited. Open circuited. Open circuited. Just I am going to doing that. Just taking those two circuits and taking that hybrid pi model and open circuiting these two capacitors. In this, open circuiting this. By open circuiting this, the equivalent circuit is therefore now low frequency equivalent of hybrid pi model. Simple. So here capacitor we have, I am open circuiting this, and another capacitor open circuiting this. This one, emitter, collector, base, it is B dash, which is RB B dash, this is IB, it is a VB dash E, it is VBE, RB B dash, RB dash C. For better understanding, I am taking in terms of resistances. RB dash C, GM into VB dash C, VB dash E, and it is RC. This is IC. VCE. This is the equivalent of low frequency equivalent of hybrid pi model. Low frequency equivalent of hybrid pi model. At the same time, I am writing H parameter model. So H parameter model. H parameter model. So this is the H parameter representation. Emitter, base, collector. So it is a VBE, IB, VCE, IC. This is a HIE, HRE into VCE, HFE into IB, and it is 1 by HOE. Now we can write the equations from this, where so now we need this circuit continuously. I am going to copying this. Now here this is going to be IC, and from H parameter we can write, instead of using that, I am going to using equations. Now equations is VBE is HIE into IB plus HRE into VCE, and IC is HFE into IB plus HOE into VCE. These are the equations. Okay, now on this circuit, now this is the low frequency hybrid pi model, this is the low frequency H parameter representation of your transistor and CE model. By applying same conditions on both, you can get the required values. What are the things, what are the modification or condition you are applying on that? Same condition has to be applied on this. To get input parameters, need to apply output condition. To calculate output parameter, need to apply input condition. Here input condition means with respect to this IB 0, output condition means VCE 0. Now first let I am taking VCE 0. First I am going to calculating input parameter R, sorry, it is RB dash E, sir. So this is RB dash E. RB dash E. Now I am going to calculating first RB dash E, which is 1 by GB dash E. First I am calculating this. This is input parameter. That's why I am going to making output parameter to 0. Now let output voltage VCE 0. Once we take VCE 0, now let us take equation number 1 and equation number 2. From equation 2, once apply VCE 0, it became IC is equal to H of E into IB. H of E into IB. Now apply the same condition on this circuit. Apply same condition on this circuit and get the value of IC. Equate both. It represents equation number 3. Let us. Now on this circuit I am going to applying VCE 0. Once VCE 0 means it became 0. Okay, it is 0. So this is the current IC. Once it is short circuited, this current is going to be always flowing like this. This is the direction of the current. Okay, this is the path. Because this is very high resistance and it is short circuited, that's why this current is flowing like this. From this we can write IC is GM into VB dash E. From this IC is GM into VB dash E. IC is GM into VB dash E. Now I want the value of VB dash E. Okay, the two. Now see this. This is the current IB. Once the current IB is coming to this point, it has to move two sides, this side and this side. It has to split. But RB dash C is much greater than RB dash E, because RB dash C is approximately of the order of 4 mega ohms and it is of the order of 1 kilo ohm. So much greater. That's why most of the base current is flowing in this direction only through RB dash E. Therefore, most of the IB flowing through RB dash E. Therefore, VB dash E is That means now it is this circuit. RB dash E. Voltage across this one is VB dash E. Now total current of that IB is flowing through this. Now we can write VB dash E is simply IB into RB dash E. Take this one, substitute here. Therefore, from this, IC is written as GM into VB dash E means RB dash E into IB. So let us take this is equation number 4. 3 and 4 both are representing IC. Okay, therefore equation 3 and 4 both are representing IC. Both are representing IC. Now I am equating that. Therefore equation 3 is equal to equation 4. From this, IC is H of E into IB. From this, IC is GM into VB dash E. Just before we calculated IB into RB dash E. And this IB gets cancelled. From this, RB dash E is H of E by GM, or GB dash E is 1 by RB dash E, which is GM by H of E. And GM is constant. From DC analysis we calculate it, mod IC by VT. This is the equation for GB dash E or RB dash E. Okay, by applying the condition at input side we calculated this. Okay, by applying condition at input we calculated this. After that, same VB dash E I am going to apply. Same VCE 0 I am applying. Now I am going to calculating RBB dash. First I am taking RB hybrid pi model, small signal equivalent, low frequency equivalent of hybrid pi model. RB dash C, GM to VB dash E, RCE, and this is IB. It is VB dash E, it is VBE, VCE it is, and this is IC. Now for this I am taking the equation second one, that is first equation, VBE is equal to HIE into IB plus HRE into VCE. Same thing I am taking, let VCE equal to 0. Let VCE equal to 0. Once VCE is 0, from this we can write VBE is HIE into IB. HIE into IB. Same thing I am doing here, VCE is 0. Once VCE is 0, no use of this, I am taking only equivalent resistive circuit. Now it is base followed by RBB dash, next RB dash E, RB dash C, connected to collector, it is emitter. emitter. This is VBE and this current is IB. You observe one thing here, both are parallel, RB dash E and RB dash C. Now this is RB dash E parallel with RB dash C, which is approximately RB dash E, because RB dash C is much greater. Since RB dash C is much greater than RB dash E, because of that. Now its equivalent is simple. Base emitter VBE, it is IB, RBB dash RB dash E. Now we can write VBE is from this IB times RBB dash plus RB dash E. Now I am equating this one and this one. Okay. Therefore, HIE into IB equal to IB times RBB dash plus RB dash E. Now here IB gets cancelled. Both the cases IB is cancelled. Now once IB cancelled, already we know the value of RB dash E. Now from this I am writing RBB dash is equal to HIE minus RB dash E. That's it. This is the equation for RBB dash. So far we calculated RB dash E and RBB dash. After that I am going to calculating third one is RB dash C. RB dash C. Okay. For this, I am going to using this circuit first. This is the circuit what we have. This is the circuit what we have. So emitter, collector, base, IB, RBB dash, RB dash E, RB dash C, GM into VB dash E, RCE, VCE, it is IC, it is IB, VBE it is, and it is VB dash E. Okay, now, and these are the H parameter equations what we have. VBE is HIE into IB plus HRE into VCE, and IC is HFE into IB plus HOE into VCE. Okay, now in this I am going to applying to calculate this IB. What I am doing is I am going to applying that IB equal to 0. Sorry, okay, IB is 0. Now let IB equal to 0 in this. Let IB is 0. Once IB is 0, from this equation we can write VBE is equal to HRE into VCE, and once IB equal to 0, this is 0 current. Now once it is 0, drop across this is 0, it is shorted to this. Now VB became VBE, VBE equal to VB dash E, and this is the VCE. We need it in terms of VCE. So this is the voltage VCE, this is also voltage VCE, it is also VCE. Now I am going to taking only this part. So it is just to simplify that. Just to simplify that, take RB dash C and RB dash E. See, this is VCE, this is VCE, RB dash E, this is RB dash C. Okay, this is VCE, VBE. Now, this is our VBE. VB dash E is nothing but a VBE. From this, I am writing VBE is equal to VCE into RB dash E by RB dash E plus RB dash C. Just I applied voltage division rule, not more than that. Okay. Now from this take the VBE, and this is VBE, this is also VBE. Just equate both. Now HRE into VCE equal to HRE into VCE equal to VCE into RB dash E by VCE into RB dash E by RB dash E plus RB dash C. And we know that RB dash C is much greater than RB dash E. Therefore, we can write RB dash E plus RB dash C is approximately RB dash E. Okay. Now, I am simplifying this. VCE gets cancelled, and now it is HRE equal to RB dash E by RB dash E plus RB dash C. Now, it can be written as RB dash E. Sorry, RB dash C. I'm very sorry. So from this we can write RB dash C is HRE into RB dash E, or GB dash C is 1 by G RB dash C, which is 1 by this, that is GB dash E by HRE. Just before we calculated the value of GB dash E. Okay, next, this is about GB dash C or RB dash C. Okay, now the remaining parameter is RCE. So next I am going to calculating RCE. For RCE, first I am taking the equivalent circuit. RCE. Emitter, base, collector. RBB dash, RB dash C, RB dash E, RCE, GM into VB dash E, it is VCE, and it is VBE. It is IB. Now our equation is IC is H of E into IB plus HOE into VCE. Now I am taking the condition here is let IB 0. Once IB is 0 here, we can write IC is HOE into VCE. Now get the IC value from this circuit by applying this condition on this. Okay. Now once IB 0, IB 0 drop across, this is 0. Now this is the voltage VCE, VBE. Okay. Now this is simply RB dash C followed by RB dash E. Nothing is different. Now here I am applying KCL. This is VCE. Let us take it is IX, IY. Okay, by applying KCL at node, we get IC is entering, IX leaving, IY leaving, at the same time GM into VB dash E also leaving. One more thing, once IB 0, VBE became VB dash E. So now we can write this as IC is equal to IX plus IY plus GM into VBE. Now I am substituting the values. Now IC is equal to IX is VCE by RC plus IY is VCE minus 0 by RB dash C plus RB dash E. Plus GM into VB dash E. I am taking VBE since VBE dash E is equal to VBE. Now just take this equation. Therefore IC is VCE by RCE plus GM into VBE plus VCE by RB dash E plus RB dash C. Here we know from previous analysis we calculated VBE, which is VCE, VBE equal to VCE into RB dash E by RB dash E plus RB dash C. Substitute this. Therefore IC became VCE by RCE plus GM into VCE into RB dash E by RB dash E plus RB dash C plus VCE by RB dash E plus RB dash C. And we know RB dash C is much greater than RB dash E. Therefore we can write RB dash E plus RB dash C is approximately RB dash C. RB dash C. Now I am doing the same thing and substituting here. Therefore your IC is VCE by RCE as usual plus VCE by RB dash E plus RB dash C. So it is RB dash C plus GM into RB dash E by RB dash E plus RB dash C. So it is RB dash C into VCE. Okay, and we know that GM into VB dash E is equal to, GM into RB dash E is equal to H of E. Therefore IC is equal to VCE by RCE plus VCE by RB dash C plus H of E into VCE by RB dash C. Just to simplify, IC is equal to, taking VCE common, into 1 by RCE plus 1 plus H of E. This is IC. And from H parameter model, already we defined, okay, that is HOE into VCE. Therefore, you mentioned IC is VCE into 1 by RCE plus 1 plus HFE. And from H parameter, IC is HOE into VCE. I am just equating these two. By equating VCE into 1 by RCE plus 1 plus HFE is equal to VCE times HOE. This VCE gets cancelled. We need 1 by RCE. Okay. And one more, sir, just a minute. Here we have, by taking this VCE common, by 1 plus HFE by RB dash C is there. Now, okay, now, therefore, from this 1 by RCE is HOE minus 1 plus HFE by RB dash C, which is nothing but a GCE. This is the value of it. So far we calculated hybrid pi conductances in terms of known common emitter H parameters. Okay, now for glance I am going to writing all the values at one point. First and foremost thing is GM, trans conductance, which is mod IC by VT. Second one is GB dash E, which is 1 by RB dash E, can be written as GM by HFE. Third one is GB dash C, which is 1 by RB dash C is equal to HRE into GB dash C, GB dash E. We check it. Yeah, this is RB dash C. So GB dash C is GB dash E by HRE. Okay, B dash E by HRE. GB dash E by HRE. Okay, that is the, and here also, sorry, fourth one, we have third one, another one, that is RBB dash. RBB dash is HIE minus RB dash E. And fifth one is GCE, which is RCE, 1 by RCE is equal to HOE minus 1 plus HFE by RB dash C, or HOE minus 1 plus HFE into GB dash C. And HFE is here, HFE is much greater than 1, therefore we can write GCE as HOE minus HFE into GB dash C. These are the values. So far we derived hybrid pi parameters, hybrid pi conductances in terms of known common emitter H parameters. Next session we derive the capacitance values C pi and C mu. We derive standard equations for that. Here are the top educators from an academy. Tiwari sir, he is the IIT topper. He has 7 years of GATE and engineering service teaching experience. and he is the author of the book GATE in 75 Days. Okay, he is going to teach the mechanical engineering. And next, Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. He teaches electrical and electronics engineering. Sanchit Jain sir, he is a computer science faculty having a teaching experience of more than 8 years. And Jaspal Singh sir, he is the ex-IAS officer. He got All India 4th rank in IAS. Scientist, GATE, state level service exams and PSU's topper, and ex-senior Made Easy faculty having a teaching experience of more than 12 years. Because of all these things, we are claiming that our educators are the top educators. See this, GATE topper, All India top rank, IAS topper, okay, well experienced faculty, IIT topper. Because of this, we are claiming that our educators are the top educators. And here are few more top educators, and here also. Now, these are the different engineering disciplines available from Unacademy for GATE and engineering service exams. First one is electronics and communication engineering. Next, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. These are the different engineering disciplines available. Now, there are two plans, Plus plan and Iconic plan. Plus plan is the basic plan to get you started, and in this, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes, and Iconic subscription. In this Iconic plan, we take your GATE and ESC preparation to next level with your personal coach by providing a personal coach. See here, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Now, once you written the exam or test or quiz you attempted, it was forwarded to your personal coach. Personal coach is the top exam expert. Okay. Now, he do the analysis on that. That means, based on your performance on that, they analyze that. That is called personalized test analysis. In that, they analyze your exam, how you written, and based on that, your performance on that, they prepare a proper study plan as well as respect to study material also they will provide to you. By following these two, every student can get success in their examinations. Okay. Now, next, Plus plan. In Plus plan, different subscriptions are there. 1 month subscription, 3 month subscription, 1 year, 6 month subscription, 1 year, 1.5 year and 2 year subscription. And the beauty here is EMI option also available. As a faculty, I recommend the students to take minimum 1 year subscription. 1 year subscription is required to complete the preparation of all the subjects and to write more number of tests or exams in that and identify the gaps in your preparation. To fulfill those gaps, you need minimum of 1 year subscription. Okay. Now, by using my code VRAO10, you get it by 10% discount. Don't forget that. Next, Iconic plan. In Iconic plan, 2 subscriptions are there. 1 year subscription and 2 year subscription. For 1 year subscription, it is 50,250 rupees. And by using my code VRAO10 during subscription, you get it by 10% discount. Okay, 10% discount you get. Don't forget that. Now, don't forget to use my code VRAO10 during subscription. Hit the bell icon for getting notifications. Subscribe us. Please give your valuable comments on YouTube. and join our Telegram group for getting latest updates on our upcoming videos. Okay, now thank you. Thanks for spending your valuable time with us. Once again, I am welcoming you all to this beautiful online learning platform and academy. Okay, stay home, stay safe. Thank you very much.